Hi, graduate student in OM Seminar 2, Operation Management Seminar 2. This is a post-week lecture. Last week, I explained what is interesting in operation management. So if you understand this paper, I think you have a good idea for your research. I explained the two paper, Garson's paper. So with that paper, I think you can have a good idea for your research. Then today, and then last week also, I introduced another paper, a research framework for business model, what is common among fast fashion, e-tailing, and ride-sharing management, ride-sharing. That is published in Management Science. So today I am going to explain a little bit about this paper. This is a more specific paper about a business model. Then you can have a more specific idea for your research. Then I explained fundamental simulation concept, underlying idea, method, issue in simulation. Before starting today's topic, announcement. First, homework announcement. You have to submit your homework on April 14. Submit your homework on April 14. I will make room in AjuBB. So submit your homework in AjuBB. And then we will have a test next week. I'll give you what is the problem for the test on next week class time. So prepare test. I'll give you what will be, but the test will be test will be homework. No, take home exam. Yeah, test will be take home exam. So don't worry about too much. Okay, very easy, and you can solve the problem easily. Don't worry about too much about take home exam. Okay, this is today's topic. First, I'm going to explain a research framework for business model. Then I'm going to introduce a new paper, supply chain management paper. It is about supply chain disruption. Then simulation dynamics, simulation by hand, randomness in simulation, simulation with a spreadsheet, overview of simulation study. With this topic, we'll have enough study today. Let's talk about paper. First, if we have this paper, look at the abstract part. This paper talk about business model innovation. In the abstract, every firm has a business model, which is the collection of a strategic decision. So business model is the collection of a strategic decision that determine how the firm generate a sustainable enterprise through the creation of enough value, it's a supply model, and extraction of a sufficient portion of that value, it's a revenue model. So Gashong view business model in terms of two models, revenue model and supply model. That's business model, and business model is the collection of a strategic decision. But it has two models, supply model and revenue model. Then it explains what is business model innovation. Innovative business model, for example, Fast fashion, Zara, e-tailing, Amazon, and ride-sharing Uber are capable of offering new products and services that generate considerable consumer utility and transform industry. So it views innovative business model in terms of offering new product and services. And then it talks about contribution. Contribution is that this paper develops a research framework for understanding business model and how business model have evolved over time. Through the framework, it is possible to identify few design decisions that explain the success of these diverse firms with otherwise seemingly disparate model and to speculate on potential future business model innovation. So it identifies some successful points and possible future business model innovation. After introduction, abstract part you can read by yourself, introduction, and then in the second part you can see business model definition and framework. And in business model definition and framework, you can read what is business model, and then there are 3 points worth emphasizing regarding this definition, business model definition. First, business model is not a single decision, but rather set of decisions that must be considered as collection. Second, business model is based on strategic decision, that is, decision that have a broad implication for the firm, and strategic decisions are difficult to change and often are made when the firm is established, thereby defining essence of the firm and endowing it with its distinctive character. Third, the emphasis with the business model is on how the firm does its business rather than what the firm offers its customer. The emphasis on how rather than what might seem misplaced because the success of many firms can be traced to what they offer their customer. Then you can see example of Zara, example of Uber. And then page 2, you can see figure 1, the component of business model. The components are customer value, resource, revenue model, and supply model. Then there is an explanation about these components. Then in page 3, innovation section, it's talk about business model innovation. Although every firm operates with some type of business model, whether they can articulate it or not, not every firm creates business model innovation, which is a business model that satisfies a novel need, has a novel revenue model, or implement novel supply model. More often than not, business model innovation involves a combination of multiple novelty in needs satisfied, revenue generation, or supply processes. Novelty often comes from challenging implicit assumptions regarding what product is important for a firm to offer or the process by which the firm offers its product. In doing so, business model innovation generally involves what could be referred to as smart sacrifice. The firm in section 3 talk about business model research, business model innovation, challenge, implicit assumption, thereby revealing new ways of doing business that were assumed to not be feasible. In effect, they provide a window to a new world that was not known to exist. Not surprisingly, successful business model garner substantial attention in industry and academy. This section discussed the academic literature on wide range of business model innovation from past few decades, including sponsored search advertising auction, Google, Priceline.com, Facebook, Netflix, Zara, Walmart, Uber, Amazon, Airbnb, and Dell, with the revenue model and supply model. Revenue model with the mechanism, structure, dynamics, supply model, timing, location, control. So for your research, I recommend you read this part carefully, then you can have a good idea of research. Then we can move to conclusion part. A firm's business model define how it delivers supply model and profit from customer value or revenue model it creates through the effective satisfaction of need. The revenue model involves high level of decision regarding the mechanism for determining process, the structure of a transaction term, and the dynamics of adjustment to transaction term over time. The supply model requires decision on the timing of resource activation, the location of resource, and the level of control of those resources. The combination of these decisions determines the amount of customer value generated and ultimately the viability of the firm. Business model innovation generally involves one or more novelty in the revenue or supply model, or both. This novelty often challenges implicit assumptions or assumptions that are so taken for granted that they would be omitted from a list of key assumptions. You can see the examples, and the business model example given suggests that there have been many successful models and they have taken diverse forms. Nevertheless, in all cases, these firms made a decision regarding the element of their revenue and supply model. New approaches have emerged when firms discovered a new combination of these decisions that in net yield better result than the industry status quo. Often, these new business models are enabled primarily by changes in technology. This pattern is likely to continue. So read this paper carefully and you have a good idea of research in the field of business model. For next paper, I introduce disruption risk optimal sourcing in multi-layer supply network by Ang E. Yang D.A. Sweeney R. It's published in 2016 Management Science. So if you are interested in supply chain disruption, then you can refer to this paper. If we have time, we are going to talk about this one, but if you don't have time, I just introduce this one, okay? So if you are interested in supply chain disruption part, then you can refer to this paper. Now, let's move to simulation part. I'm going to talk simulation part about simulation dynamics, simulation by hand, randomness in simulation, simulation with spreadsheets, and overview of simulation study. Now let's talk about simulation dynamics. Usually when model simulation in compute, we code with this view, event scheduling world view. Identify characteristic of events, then decide on logic for each type of event to effect status change for each event type and observe statistics, update time of future event. And here we keep a simulation clock and future event calendar and jump from one event to next, process, observe statistic, update event calendar. In here we must specify appropriate stopping rule, usually done with the general purpose programming language, C++, Java, MATLAB, Fortran, etc. So when we code simulation with the programming language, we generally use this one, event scheduling worldview. If we apply event scheduling worldview, then we can use this logic for arrival event. So arrival of a new part to system, we update time persistent statistical accumulator from last event to now. So we can have area under Qt, max over Qt, area under BT. Also we mark arriving part with the current time, and if machine is idle, we start processing, mark machine busy, tally waiting time in queue. Else machine is busy, put part at end of queue and increase queue length variable, and then we schedule next arrival. This is for arrival event. Then let's see depart event. For departs event, when service is completed, then we can use this logic. Increment number produced statistic accumulator, compute and tally time in system. It is computed as now minus time of arrival, and update time persistent statistic. Then if queue is non-empty, take first part out of queue and compute tally its waiting time in queue, begin service. Else queue is empty, then make machine idle. This is for depart event. So if you model with the general purpose language, you should keep in mind arrival event, departure event with this logic. At the end, we have to update the time persistent statistic to end of simulation and compute final output performance measure using current values of statistical accumulate. After each event, event calendar's top record is removed to see what time it is and what to do. Also must initialize everything at the end of simulation. Some more additional specifics for the simple processing system. We have a simulation clock variable. It is actually internal in Arena, and also we have event calendar. That is a list of event record. In event record, we have event number, event time, event type. Keep rank in increasing order on event time, and next event always in top record. And initially schedule first arrival, and we are also schedule the end. Status variable. We have a status variable. It describes current status. Serve status is 1 for busy, 0 for idle. We also have a number of customer in queue. It's a state variable, and time of arrival of each customer now in queue. It is a list of random lengths. Let's see simulation by hand. It is event-driven hand simulation. Okay. So we will let you have the detail of hand simulation. So we will manually track state variable and statistical accumulator. We will use given into arrival and service time, keep track of event calendar, and watch clock from one event to next. We will omit time in system and max computation here. For complete detail, you can see the simulation textbook, simulation with the arena. Now let's see simulation by hand. This is a setup. You can see event calendar and inter-arrival time, service times are given. At time t equals 0, initialize. The model is initialized, and with all variable and accumulate set to 0. The queue empty, drill press idle, and the event calendar prime with the first arrival happening at time 0, and the end of simulation scheduled for time 20. You can see here. To see what happens next, just take the first event record of the event calendar. This part. The arrival of entity 1 at time 0. Now let's see at T0 part 1 arrived. Then you can see this event record. Entity 1 at T0 arrived, then next part arrival is scheduled by creating part 2 entity, setting its arrival time to current time plus its inter-arrival time. So you can see here, second inter-arrival time is 1.73. It's checked. And placing it on in the event calendar. Meanwhile, the part arrival now makes the drill press busy, and arrival time 0 of this part is stored in its attribute. The queue is still empty because this part finds the drill press idle and being serviced immediately. Since the entity passed through the queue, n is incremented, and we check to see if a new maximum waiting time in queue has occurred. There has been no production yet, so P stay at 0. The service time for part 1 is set 2.9 minutes, this one. And part 1 entity return to event calendar. Taking the top record of the event calendar, next event will be arrived of entity 2 at 1.37. So here. At t equal 1.73, arrival over part 2. Next part, arrival is scheduled by creating part 3 entity. Setting its arrival time to current time 1.73 plus its inter-arrival time 1.35. So, next arrival, third arrival is scheduled. And placing it on the event calendar, which scheduled the arrival of this part at time 3.08. Meanwhile, the part arriving now find the drill press already busy, so it must queue up. The drill press is still busy, so BT just stays at 1, like here. But the queue length is incremented from 0 to 1. The queue length is increased. Now there is a queue and the arrival time is stored as attribute of the part in queue. Part 1, which arrived at time 0, is still in service. This event has resulted in no new production and no new time in queue observation. You don't update time for the next departure since it's still scheduled as a departure time over part 1, which arrived earlier and is now partially processed. The next event will be departure of part 1 at time 2.0. So event calendar, next event will be here. At t equal 2.90, departs of part 1. In system, part 2 is in service. Since this is a departure event, we don't need to schedule next arrival. It's already on its way with the arrival event 3.08 arrival. This one. And part 1 is now done being processed by drill press and ready to depart. Since there is a queue, the drill press will stay busy. So BT remains at 1. Here. And QT is decremented. And Q becomes empty. Part 2's waiting time in queue of duration 2.90 minus 1.73, so 1.17. Has now been completed. A finished part has been produced, so P is incremented. And the total time in system of part 1 is computed 2.90. Next service time is 1.76. So next departure will be at time 4.66. So this is the next departure. And next event is arrival of part 3. So this one. Then this is at time 3.08, arrival of part 3. You can interpret as before. This is a simulation by hand at time 3.79, arrival over part 4. And you can see system, system status and clock, and total of waiting time in queue and other part. Then we continue at t equal 4.41 arrival of part 5 event and 4.66 departure of part 2, 8.05 departure of part 3, 12.57 departure of part 4, t equal 7.03 departure of part 5, t is equal to 18.69 arrival of part 6, t equal 19.39 arrival of part 7. You can see these events and what happened to record. You can refer to the textbook. At t equal 20, we stop the simulation. The only task here is to update area Q and B. QT graph and BT graph. Then we have this result. Finishing up, average waiting time in Q is calculated by total number of time in Q, 15.17 divided by number of times in Q, 6. So 2.57 minutes per part. Time average number in Q is area under Q curve 15.78 divided by final clock value 20. So 0.79 part. Utilization of drill press is calculated by area under BT curve divided by final clock value. So 18.34 divided by 20. We have a 0.92. And this table shows complete record of a hand simulation. You can see similar table in table 2-2 in your textbook, record of a hand simulation. So all the complex number is in this record. So from previous logic, event scheduling logic or hand simulation, what kind of feeling you have? It is clearly well suited to standard programming language, C, C++, Java, etc. You can use a program language, then you can build up the simulation. Is that right? Often, so if you use that language, you can use a utility library like list processing, random number generation, random variate generation, statistics collection, event list, clock management, summary output. Using this library, you can program that. And main program ties it together and execute event in order. Okay, so using programming, you can do previous example. Simulation dynamics process interaction worldview. Event view is what happened in the real programming, right? But for easier programming, we can use a process interaction worldview. Here, we identify characteristic entity in system. First, identify entity, then multiple copy of entity coexist, interact, compete in process interaction worldview. And code is a non-procedure. We tell a story about what happened to a typical entity, then it is automatically programmed. We may have many types of entity, fake entity for things like machine downs. We usually requires special simulation software such as Arena. But in the underneath, still executed as event scheduling. We just use easy program with Arena, just tell a story with entity. But underneath, the software executed as event scheduling. This view is normally taken by Arena. Arena translates your model description into program in Simon simulation language for execution. So if you use Arena, it has a process interaction model, so you can easily program the simulation. It shortens programming time a lot. But underneath, Simon simulation language is executed. Let's see randomness in simulation. Above simulation was just one of replication, a sample of size 1. Made a total of 5 replication. So if we have 5 replication, then we have this result. This is total performance measure, total production, average waiting time in queue, maximum waiting time in queue, average total time in queue, blah blah blah. And then all this number is the same? No, it's not same. So we have a randomness in our simulations. And then you have average, standard deviation, half width. Then you can construct confidence interval. Confidence interval for expected value is general. In general, x bar plus minus t n minus 1, 1 minus alpha over 2, s divided by square root n. If we have a normality assumption. And for expected total production, you can have this value, 3.8 plus minus 2.04. Is it precise? Half width is too wide. That's what randomness in simulation. So when you interpret simulation, we should be very careful about randomness. Comparing alternatives. Usually, simulation is used for more than just a single model configuration. We try many configurations. Often, you want to compare alternatives, select or search for best model, best configuration. Simple process system. For simple process system, what would happen if arrival rate doubled? Well, this is what if analysis. Cut into arrival time in half, return model for double time arrival, make 5 applications. Then let's see what happened. And this is the result, original and double time arrivals. Original is circles, and double time triangle. Replication 1 filled in. Replication 2 to 5 is hollow. We can see variability. For each total production, average waiting time in queue, average total time in system, time average number part in queue, drill press utilization, you see variability. So danger of making decision based on first replication. There is a danger of making decision based on one replication. But hard to see if there are really differences. So we need a statistical analysis simulation output data. Let's talk about simulation with a spreadsheet model. It is a very popular and ubiquitous tool. Can use for simple simulation model. Typically, with spreadsheet, we simulate static model for risk analysis generally and financial investment scenarios. Very simple list of a dynamic model. Well, with the spreadsheet, we can do a dynamic model, but very simple. If we have time, I'm going to introduce two examples. First, the new spend problem, static model, when waiting time in single server queue, dynamic model. If we have time, I'm going to explain two examples. Overview of simulation study. No simulation study will follow a cut and dried formula, but there are several aspects that do tend to come up frequently. First, understand system. Whether system exists or not, you must have an intuitive, down-to-earth feel for what's going on. This will entail site visit and involvement of people who work in the system on a day-to-day basis. Second, be clear about goal. Realism is the watchword here. Don't promise the sun, moon, stars. Understand what can be learned from the study and expect no more. Specificity about what is to be observed, manipulated, changed, and delivered is essential. Return to this goal throughout the simulation study to keep your attention focused on what's important, namely making decisions about how best or at least better to operate the system. Third one, formulate model representation. What level of detail is appropriate? What needs to be modeled carefully? And what can be dealt with in a fairly crude, high-level manner? Get busy into the modeling assumption from management and those in decision-making positions. Then next one is translate into modeling software. Once modeling assumptions are agreed upon, represent them faithfully in simulation software. If there are difficulties, be sure to iron them out in an open and honest way rather than burying them. Involve those who really know what's going on. Animation can be a big help here. Next one is a verify. Verify program. Verify then your computer represent the conceptual model faithfully. Prove the extreme reason of input parameter. Verify that right things happen with the obvious input and work through the logic with those familiar with the system. Next one is a validate model. Validate model. Do the input distribution match what you have observed in the field? Do the output performance measure from the model match up with those from reality? While statistical tests can be carried out here, a good dose of common sense is also valuable. Then design the experiment. Plan out what is you want to know and how your simulation experiment will get you to the answers in a precise, efficient way. Open principle of classical statistical experimental design can be of great help here. Next, run the experiment. This is where you go to lunch while the computer is grinding merrily away, or maybe go home for the night or the weekend, or go on vacation. The need for careful experiment design here is clear. But don't panic. Your computer probably spends most of its time doing nothing. So carrying out your erroneous instruction doesn't constitute the end of the world. Remember, you are going to make your mistake on compute where they don't count rather than for real where they do. Then analyze your result and get insight and document what you have done. Carry out the right kinds of statistical analysis to be able to make accurate and precise statement. This is clearly tied up with intimately with the design of the assumption simulation experiment. This is far more easily said than done. What do results mean at the good level? Does it all make sense? What are the implications? What further question? And maybe simulation are suggested by the result. Are you looking at the right set of performance measure? Final one is document what you've done. You are not going to be around forever, so make it easier for the next person to understand what you've done and to carry things further. Documentation is also critical for getting management buy-in and implementation of recommendation you've worked so hard to be able to make with precision and confidence. This is an overview of whole part of overview of a simulation study. Understanding system, be clear about goal, formulate model representation, translate into modeling software, verify program, validate the model, design experiment, make runs, analyze, get insight, document result. By paying attention to these and similar issues, your shot at successful simulation project will be greatly improved. Okay, let's finish today's lecture here. Today I explained a reader research framework for business model. What is common among fast fashion, e-tailing, and ride sharing? Published Management Science 2019. It's good paper for business model. And then I introduced a new paper, supply chain disruption paper. So if you have time, read that paper. And then simulation dynamics and simulation by hand. We run. And randomness in simulation with spreadsheet. I just mentioned that part, and then next time, if we have time, then I'm going to teach this part and overview of simulation. Okay. Next week, I'm going to give you a test and submit your homework in AjuBB. Next week is due. And then I'm going to give you one more homework. Summarize this paper, research framework for business model. 5 to 10 page, A4. Due is April 28th. So we have 3 homework, 3 paper summarization. Okay. If you have a question about homework or test, you can email me or you can use AjuBB. Okay. Today's lecture is done. Enjoy your time. Thank you for your attention.